gel
the
12 rounds,
first one.
2 protein work.
This is your, okay, I see it. And, okay. You guys are all looking at your, see, like, this is a really good antibody, so this one shouldn't.
Yeah.
Is this the one that, the gel 2? This PPAR gamma, is this the one? I think this is the one. I feel like you should, I don't know.
I could redo this. The
That-
strip and
Yeah, well, but is the stripping actually getting,
So the thing when we do the stripping is it strips original the protein versus like our new
it should
targeted,
just, your protein is immobilized on the blood. That's not going to strip off. What strips off is the antibody. So, but you were saying that you still had residual left on the blood when you stripped.
Yeah.
Did you solve that problem with the Triton X?
So I think if I just increase 5 times, it works. But
Okay.
the thing is, the residual is getting like smaller and smaller once I blot it, and it recognizes the residual of the first one, the first primary.
No, I'm going to have her redo this because this isn't good.
Yeah.
Like this, I mean, I can sort of see, but there's just something weird about this blot. But because this is where you showed the interaction.
As long as it shows in the total, then yeah, it should there about.
And this is your high fat, so I don't know. And remember, this is a different question. PPAR gamma directs osteoblasts and adipocytes, right?
Yes.
We're looking at the impact of high fat on PPAR gamma, so it's a little bit different of a question.
Yeah.
So, like I said, it might not show anything, but I want to just be confident. So there, yeah, just that gel 2.
okay. What about I think I can redo gel 3 as well.
So this was gel 3. I mean, this one has CRISPR bands. So this is,
Gel 1 and gel 2.
and
Very clear, and these are not also very clear.
And so you're only, so are you saying, so this is about a 60 kilodalton protein, right?
Yes.
So doesn't this, are you not analyzing these bands as well?
No.
Because this is 75. So this is 75, right?
Yeah, I'm just taking the lower ones around
Well,
50.
I would actually,
50 and 75.
yeah, so what I don't understand is,
So the mine one was like a little bit like a higher, was
Yeah,
also shown
yeah,
up.
Yeah, I didn't do this one.
so I think that you should be doing both of these. Because look at your antibody, I'll show you. Your antibody gives you isoforms.
Yeah.
See how it has a diplet?
But not really high molecular
Yeah, but
weight,
that's
but
what I'm saying.
still like a
all
40.
of them are around 55.
Then that's similar.
But 60. So I
Mm.
that
60
was
is, I
way
think,
that was
is
way
also-
under your bands.
This
were
one
way
is
under
was another. This
75.
one was also like more than like almost like
Yeah. You see how his is under 72?
there is a little bit more like upper band.
You see how
Sometimes
you
it's
have
also-
these, like, here's your 75. I wouldn't do this band, but I would definitely do these two.
Yeah.
These.
That's possible.
That's what I think I wanted to look at. So go back and just redo this analysis.
So that's written in the
Mhm.
for the like so we just use like a really mild stripping, like just 1x, and then just like a rinse, just like take out the
Mhm.
secondary. Then we just like
Well, you want to take off the secondary and primary.
yes. But the thing is, if it's really like bind strongly, then it's gonna anyway the residue is gonna show up on the like new bloody. So
You mean like if it's the primary is not coming off?
because we use a secondary antibody, so it just automatically recognizes the residue of the old one. So
Mhm.
even though the signal might be like looks like not, we ideally think it's stripped out, but it recognized and then it showed up like
Yeah, it should have.
So didn't he say to just go up higher concentration on the stripping
Yeah,
buffer?
yeah, yeah. But it works. But the thing is, we lose our protein as well. Like both of, and
How do you? Their protein is stuck on that. It's
So-
stuck.
So just when I just compare like before and after the after the stripping, we see like the original one is like stripping out.
I mean, that makes no sense because your
Mm.
proteins are immobilized.
Yeah,
But-
that's actually
But
true.
what, like, we have observed, initially after stripping, if we scan, there is nothing. But then again, when we add the primary and
That's
secondary,
because
the previous
secondary
blocks
signal.
showed up.
Hmm.
So like one of Sana did like for the 32. So and she did was she did third one and then she brought it with another one and then like just to use like a really mild condition, then just to find like you said like a empty spot.
So basically, when you're doing a different molecular size marker,
Yeah.
your old one's showing up as well.
Yeah,
And that's even when you went up higher, right?
yeah.
I haven't read 5x yet.
But that's what I remember you telling me. That's what the company said, right?
Yeah, the company.
And you're
Company
afraid
said-
that that's going to take out your protein.
Yeah.
I mean, I don't care if the cert one stays there.
Yeah.
I mean, I just want to get a
New
better
protein.
signal. That's all. So with these, I would just
or because we just have like we all have like a mouse monoclonal, but we have like a polyclonal pipa gamma, which can recognize the
Poly-
other channel, red channel.
we have a polyclonal. I would use that one.
We have a red one, just
Oh,
only the pipa gamma rabbit, then it can recognize with the red channel. So that's what. The
and we
company-
have different secondaries.
Yeah,
That
we
should,
have
Yeah, yeah,
green
yeah.
and
so
red
would you, because you've already stained it, is that going to impact on that?
I don't think so. I mean, no, shouldn't be.
Well, but you stained with Revert 700.
Yeah, but then.
So we check it's just to go away when we actually the blotting our the final one, we check the 700 and it's all clear.
Is it?
Yes.
How did that happen? Just with
For
washing?
for us every time, mostly like
How does it? How come it goes away?
I think we just blocked. I
Yeah,
don't know.
didn't he say that you can? Isn't there a procedure for removing the Revert 700?
That's
destaining?
that's the destaining, but Dr. Leaks they use 11 minutes. But you said it's creepy and just washing and
So just the washing is getting rid of it.
washing could be like excessive, but we don't do destaining. But for some reason it's gone.
Okay, well then do the polyclonal in the red channel.
Pipa gamma.
Yeah, because
That's
polyclonal's
the-
better because it's going to recognize, just like he
Mm.
said, different epitopes of the protein. Okay, good. So just redo that one, and then for yours, let me see, make sure I look through everything. So here's when you're looking at the row factor. So this is significance. But what are you comparing here? Like, what is this? This is nut. This is this is normal diet, high fat, and then this is. You're saying this is different than this?
Based
So-
on treatment, there is a difference.
Okay, but you're saying that for normal diet compared to high fat diet with the inhibitor, those are the difference, or is this? What is this? This to this?
I think it's this to this. The treatment versus the treatment. Like
This-
normal diet treatment versus high fat diet treatment.
That is that is like what I'm going to call a nonsense comparison, because so the comparison would be this to this, this to this, or this to this, because normal diet to a high fat diet treated with the inhibitor, that's that even though statistically it's showing something, it doesn't mean anything.
How I set up my table.
But did you both get the professor, the stats professor? Why are they making him sign the register? They've never.
And
So that's what Sherry just asked.
I know why.
He just said okay, and she just keep asking like,
But
where is the sign? And
I
then
know
I was
what.
like, so sorry because he looks like so, you
But
know.
but we've never had to get that sign before.
I
So
know.
what is going on?
Yeah, I
Maybe
sent
just-
I sent her the email of Dr. Bush where he said like, okay,
Yes,
you
it's
can
okay.
join, but then she was like, no, I need you to sign the registration form.
Okay. It's weird. It's new.
Okay, so the rho factor is between 0 and 1, like between control group and treatment group there is a significant. So it could be
So you're saying that you just meant that all of these are just showing that there's some interaction with the inhibitor,
yes,
but not anything specific.
not anything specific.
Because you did a two-way.
Yeah.
Okay. All right. And then this one, nothing. This might change though because you're going to redo your because you weren't capturing all the bands.
Yeah.
We'll have to see what happens with that. And you know what the problem is because there's so much fewer animals here, so you're getting that spread. Like look at 2 down here. So you basically not showing anything with the high fat. With the normal diet, you're not even detecting P per gamma.
It's very low.
I think that this might change a little bit when you use a different antibody.
We're talking about these 2 parts, like 0.0026
Yeah.
and
Okay.
0.003.
And then remember, this doesn't go below. There's no negative value, so your axes just go from 0 up. So now this is showing again a trend. So basically, what this is saying is, and we don't have to even include this, but it's basically saying that in this case, did you just do these 2? Just these to this? Take out this group.
Okay.
And just we'll see if that leptin inhibitor is doing something. Because you're definitely having an effect here.
So I think so.
When you do the analysis, just you can just select the 1 mg. Okay. I just wish that this protein would show up better. What does your uncoupling protein one look like? Are you getting these really faint bands too?
So mine was. It's like just a single.
Okay, but you're getting a little crisper. So this was different. Afsana.
Yes,
Oh, that's good.
that's after multiple comparison.
And you're okay, good. So you're definitely seeing that there's so leptin somehow is involved in this process with, at least I'm trying to like get clues as how is this uncoupling protein 1 regulated, so that's good. And this is good. So this is just a synopsis of everything. Like that looks nice and clean. Look how tight that, and you're removing that variance. Okay, so this is the muscle. And again, like P part gamma, RUNX 2 has a spread.
Yes.
So I want to make sure that you're picking up the spread.
No, I think I did.
Can I see your trisol extracted proteins? Because melatonin, those are the animals that we showed that RUNX 2 went up.
This is the trisol extract.
Oh, okay. So where's your 75? Is it this band right here?
This band, like between this red and this red, I think it's not set.
It shows like
Why
a
it's,
yellow.
it's the new molecular weight marker, so it's a bit different than the one we used before.
So for the new one,
70.
it's not showing up. It's
So-
a jump.
So between this and this there is another marker. Like you can see it faint here.
Yeah.
This is 72.
Okay, so your bands that you should be highlighting are,
These two.
so here's your 72. You should be highlighting these.
Yes.
Okay. I think I just
Yeah, you're
went for
missing.
the bottom one.
No, you got to do both of these.
Oh,
'Cause they're all under 72. So RUNX is like, like you see, this is a 77.
Yes.
So and it goes even under to like 43. Let me see where's your 43 in those plots?
43 would be 43, 1, 2. Like
Yeah, so you're gonna take the bands between those two underneath the 72.
This is 43. This is 55. This is 72. So
Okay.
all this.
So all of this.
Okay. I think I just took this lower one. I didn't include the upper one.
Yeah, we'll see what happens with that. Because the rungs too, because those are the bones that we did so
Yeah.
many assays on those that
Yeah,
that
yeah.
goes up.
Yep, yep.
P par gamma, I mean, P par gamma, it should go down. We'll see. Okay, but these are looking really nice. Like your bands, like look at how nice that is. Those are really crisp, nice bands.
Oh wait, I think I took the whole thing. For
Yeah.
us to-
For rungs too, this is the muscle. This is your
LNC. I took the whole thing. I just didn't take the whole thing for this bench and one. I should do this,
mhm.
but for the rest I took the whole thing.
But can I see your grayscale? I like working on the grayscale because I can see the bands better. So where is 43 on here?
This is 43. This is 70.
So this is what,
This is 55.
but you're gonna take all these, right?
Yeah.
And that's what you took before?
I took for this. For this one, but for this I
Yeah, you have to go
went
all the
a
way
bit
down.
Yeah, I have.
Because you're not including a lot of
Yeah.
things there. But look at how nice these are. That looks good. So you're not so you're not seeing anything for rungs 2 with the diets. Yeah, Western blots, it's always kind of fun for me to see your techniques getting so much better now. And they're just a finesse.
ACRP, there is a column factor, not significant, I think trend, indicating that diet has to do something.
What was the trend?
In ACRP,
What? Yeah, what?
two-way ANOVA,
Not a p-value of 0.1131, right? It was under 0.3 or 0.1. I don't. Where did you see the column factor?
I think I did a two-way ANOVA and then something showed up.
Oh, this one.
Yeah.
And the column was diet,
Yes, the column is diet.
and this is just comparing just the high-fat, non-fat to 1 mg per kg.
Yeah, yeah.
Okay. Or normal diet. Okay. And you took both because this is again has a range 50
Yeah,
about
I just
60 to
I took larger pens. The upper one is for cert 1
okay.
and the lower is 4.
So this is the CEBP, and you see your gel's kind of going on an angle. Did you make sure that you did it this way? Because you see how your gel is not straight across. So did you you see how it's kind of going up? How did you?
For gel 3, I just
Yeah. So another thing you guys have to always look at. You see how her gel's going up?
okay.
You have to readjust that because this is going up. So you have to because this is your double band, and here's your double band, and here's your double band. That sometimes just happens because you can follow this. You see this?
That might be just when we do the transport
Yeah.
membrane.
So just make sure that you're just lift up your boxes because you're again cutting off a lot of stuff there. And you kind of have this marker here. I would do like this one here. Then you see this two here. Then you have these two here, these two here, these two. Okay. Because look at how it's going this way. You see how this is kind of going up. So you should be taking this box. You don't go straight across. That's why you have to kind of look at the quality of the gel too. And sometimes that just happens.
Yeah.
This one, same thing? Is
Yeah,
this the same?
Yeah.
But this one is straight. So these are good. Yeah, you just have to kind of sometimes, even like when you do the total proteins, remember how sometimes you're
Yeah.
Yeah,
It's
it's
diaphragm,
like,
so you have to kind of
yeah.
shift it because that will throw off all your data if you don't do that. Yeah, so let's have you have a couple more things you got to do, and then just update this.
Yeah.
Just update this file
Yeah. Not
and
new
your
file.
Prism file. Don't give me any new stuff.
Okay.
Okay, but at least we're seeing something. And then how about cert 1? Let's see. So is this what you're saying is your band?
Yes.
Yeah, you can kind of see the smearing a little bit. And then LMO3 is a small protein. Oh, that's the fusion, but it's normally like under 23. Didn't that new Odyssey like find your bands? Isn't that what the demonstration showed? It like highlights all the bands instead of us having to do it. Do you remember? Did you guys sit through that new one, the new imaging equipment?
That's what we
I
do.
think they use Imperio Studio instead
That
of
we
Image
don't use
Studio.
the software, but
Because it will find your bands and highlight everything for you, so it would like. But I mean, I still stick with what you're doing here. But I was just thinking it might like be able to like see how this is going up.
Yeah.
This would be your LMO3. So you have to.
For that I do.
Okay, so you were doing that.
I need to redo the CEV.
It's amazing how tight those bands get, you know. Okay, so just redo but these are looking good. I just want to have like a clear idea. So when are you going to have your Western blots done?
so right now I'm almost down for the ACRP and then still working on the cert and then doctorate and B. So for the cert, I'm really like right now I'm really biased. So I feel like the band a little bit lower band might give some idea because when I found just probably some of them is they have a lower band, but mostly like 120-ish. But still,
But look at how, I mean, they're going from like 132 all the way down to like around that 80.
Yep. Also,
82.
yep. So also they I try to calculate the molecular weight with the sequence from the
But
company.
but a lot of times it's the post-translational modification.
That's why it's
Higher.
120.
Yeah.
But what if it's I mean that was my
Well,
my
sometimes
just,
you're going to get different forms of that protein when you're running it out on a gel.
yeah.
That's probably why it goes from 132 down to like 80, 83. So can
Yeah.
I see what you're doing with your blot?
So so this is third, and then I was like try to live like a more like a linear. so I was curious like what is this upper band in between this and this one, because this one is 130, so
Where's 130? Right there.
the red one, and then this one is 95.
Yeah.
So
I
what
would
if-
take this. According to those, I would take from, is this 130?
that's
this one?
170.
Where's 130?
one-
I can't. Where's 130? Right here?
Yes, this one is 130.
And then, yeah, but you have to capture all of that,
Yeah.
all of this.
So for this one, it looks like.
So I think it's here.
So this one was like, if I just like assume like they are like parallel. Then,
Well, that's a straight blot, so you can just go across.
Then other one is like looks like this one looks like higher than the 95. So this wait. So. One second. Oops. So because the upper part didn't transfer well, so this one is 95 70 wait 95 72, and
What's that like? What's this band?
so it's I can make like a strong.
What's that one right there?
So this one is 9.
But what about this band?
Yeah, that's
Isn't that
170, 130, 170, 130, and
Okay, but
90.
I see that you're kind of cutting off part of that 130. You have to like put that box
Yeah.
completely
So-
over it.
So if I choose like in this range, if I choose like this range, then if the gel is like a parallel,
Mhm.
then it's more than this one is more than 95, so I might think this might be the third.
Yeah, but you have to capture
Yeah,
one
yeah,
between
yeah, yeah.
132 and 80. So I think
Even 90.
so. Here's
because
here.
the
So
previous
this
one.
has to be. You have to bring it over that band.
Yeah,
So here, pull that up
yeah.
because it's cutting right through that
Yep.
protein.
Yep. So this one also I just
Just make
try to
it.
see
Just bring
the-
it up just a tiny
Yeah,
bit
yeah,
so
yeah.
that it takes that whole band in, and then
Yep.
just go across that.
Yep.
Because but why do you have them way up here? Because that's 175, right?
Yeah.
So all your bands, just keep it.
Yep.
And what's that one?
That one is 70. 55.
Yeah, that's too low. So I think this is your box.
Yes.
And just
70
bring that box all the way
Yeah,
across.
yeah,
So you're right. I think that's your band. right
And,
there.
Yeah. When I roughly try to finish, then I could only see one like a trend, which one was CBP, normal diet versus high fat diet. After purchase correction is
Well, you have so 0.08.
yes, and otherwise it's like almost like a borderline, like a 0.1 something. There are
Oh.
some certain things, but it's not like it's
Okay.
really cut off.
Yeah. So just finish everything.
Yeah.
Put it all in the same PowerPoint, and then and don't separate out your grubs.
Yes.
That all stays in one Prism file.
Okay.
Just label it on your
And-
thing that says like no grubs,
Okay.
outliers
Okay.
excluded.
Okay.
just so we know.
Okay.
But all of it just on
Okay.
one Prism file.
Okay.
And that Prism file is going to be called high fat bones or
Yes.
2-lane high fat bones
Yes.
because hers is high fat muscle.
Yeah.
2-lane high fat muscle. So when do you think you're going to have that done?
Almost
Okay.
today. Or tomorrow.
Yeah, just try and hit your deadlines because we got to get on the cell work.
Yep. And we try to do inventory, and then we are not
Yeah,
sure what the radio, the shelf.
What?
Like the radioactive area, do you want us to go there for
There's not,
inventory?
is there anything there?
I don't
Not much, but
like we see the solution over
Oh,
there.
that's just buffer.
Okay.
There's nothing there.
Okay. Then
Just the stuff that's over here in the corrosive flammable.
Yep.
I think we threw out a lot of stuff too.
Yep.
All right. Can we switch to just your cell work? So I was talking to Asana before the clinical trial person,
Yes.
and so whenever you have free time, you need to start entering data. Like that is a given. And I need those tables made, remember, with the melatonin saliva sampling time.
Yeah.
And then you go in with the watch and just calculate the lux
Yep.
intensity for that. And you're going to do that so Asana can make you just go participants 1 through 63 or whatever. That in itself, just the data analysis is going to take a long time. So that's always a given that if you have downtime to start entering data. I would like it if you both work together, so two pairs of eyes will prevent mistakes. So but now the cell work that I need for the grant is I'm trying to teach you guys how to write for like grant-like.
Yeah.
So basically aims 1, 2, and 3 in my grant all will be looking at these LNC RNAs either through treatment in bone, but then I validate them in the cell lines.
Yep.
Just like that one paper we reviewed was like perfect.
Yeah.
They did some treatments, they plated them, and then they manipulated the RNA. So what I sent you this morning is I'm trying to determine how PPAR gamma is modulated. And I'm thinking that melatonin is inducing LNC RNAs that are sponging microRNAs or not, or acting maybe not with microRNAs wherever we can see that, to manipulate PPAR gamma that will then manipulate what the cell fate is. So what I was trying to, and then we also need to determine like the proteins that are also involved in the adipogenesis and the osteoblastogenesis. So what you guys have to look for are LNCRNA kits. Do they have mimics and inhibitors? Like I know they have kits. Just buy these kits. I need the company. I need to know what the cost is.
Yep.
And how the assay is run. But following a kit's very simple. Then if then I need to see if there's mimics and inhibitors of those microRNAs, that the table that I gave you, because that's the table I'm using.
Yeah.
And then we're going to do Western blots on those proteins that they're linked to.
Yep.
And then also we're going to be doing alizarin red in a
Yep.
dipogenesis. And was it
Yep.
oil red O? Or dipo red or something? Like
Alizarin red
the
for
oil.
osteogenesis.
What's the oil? What's the
Oil red for
was that what it was called? Oil O red?
Yeah, yeah.
Okay.
For
There's two different kinds.
for the-
Yeah.
I thought it was called a dipo red.
Yeah.
So basically what we're doing in AIM 1, we're going to do MSCs, human and mouse. And Bruce Bunnell said he's going to be sending me mouse stem cells.
Yep.
Then what we're going to do then is we're going to either do whatever those LNC RNAs I chose, we'll do a mimic, we'll transfect them in those cell lines, give them vehicle or melatonin and see what happens to that LNC. Well, the first thing we're going to do is just do the treatments and then just see if that LNC RNA, microRNA, and those proteins are changed in those cells. That's the first thing. Now, then we're going to start manipulating the LNC RNA.
So we will use the Dr. Lawrence qRT-PCR.
Well, we were talking about that. For now, we're going to be pretty simple.
Yeah.
I want you guys to just get your technique of
Yeah.
working with cells, because
Okay.
stem cells are not easy to work with.
Yeah.
As you know, because you take over. They're weird. They get like long and just strange sometimes. But the first thing we'll do is I want to just verify what we found in the bone. And so I think what we would do is this is why I set the time points. Because usually in these assays, alkaline phosphatase doesn't come on until about day 11 or day 10. But the calcium deposition for the osteoblasts come on at day 21. So let's just say we're going to do vehicle and melatonin treatment. And then we're going to just look to see if these LNC RNAs that we have in that table change. And if they're accompanying microRNAs, change. And then if they're accompanying proteins, if any, change. And how that impacts on the ability to differentiate into an osteoblast or an adipocyte. Then you start to do those, and just like that paper, you start doing LNC transfections. What does that do to those proteins? But now we're removing the treatment. We're just doing LNC RNA.
Yeah.
What does it do to the microRNA? So on and so forth. And then we're going to go down to the microRNA,
Yep.
mimics and inhibitors.
Yep.
Some of these LNC RNAs we don't really know anything about, so there's no kits on them. So we might not even be. The only thing we would possibly be able to do is just make them. Have a company synthesize them for us. And we transfect in that LNC RNA. Because sometimes they won't have kits on these because they're just, people don't know anything about them. Because this is a really new area. A lot of those microRNAs have kits and, have inhibitors and stuff like that. So I'd want to use mimics and inhibitors of those. So we're basically saying, does melatonin do this in the stem cell like bone? But what I have to figure out is when to assay them. So I'm thinking, assay them what? I'm afraid, like in that paper, how long did they, remember that one paper when we were at Starbucks?
Yes.
When did they assay, because I don't want to miss that blip. Because the LNC RNA might go up and then go down. But I'm trying to remember the paper because I think I put it away. Do you guys remember what the paper was? It was the most recent one we did, and I said, no, that was the fat paper. It was the paper before that. Do you remember which one that was?
I think it's the circulating RNA responses.
So-
Either these or the LNC tag.
Wait, they're going to ship the cells on the 17th. I have to figure out that. So let me see. What was the paper?
What was it? This one?
Yeah, that's it. That's the Pure J.
This one. Not this one.
That too. So both of these papers. Look at both of you got both two different ones. That was the Young has the melatonin
Circular
paper.
RNA.
Huh?
Circular RNA sponges, microRNA.
He has a circular RNA one with the sponging, and then yours is just the LNC RNA. So both of these, look at the way they write their methods.
Okay.
We're following that methodology. We're just not using circular RNA.
Yep.
But we're basically going to do the same thing. Can you send that paper to me again? Because I need to better label that. But I need for you guys to kind of write up the protocol for that. Oh, and the other thing we're going to look at is their effect, the LNC RNA's effects on PPAR gamma. So I don't know if these are going to be, I'm thinking they're going to be regulating more levels rather than activity. But I think you can look at activity of PPAR gamma by looking at its phosphorylation state. So, because just like they do in those papers, it's like melatonin, let's say, upregulates LNC-RNA, and let's say that sponges this microRNA that's regulating PPAR gamma, that's regulating the switching.
Yeah.
That's kind of what we're looking at. Does that make sense?
Yes.
Because everything in the grant is PPAR gamma driven. And then PPAR gamma then does all these things to those other proteins to direct the adipogenesis and osteoblastogenesis.
Yes.
So we have to, that's the focus of, and then what I was telling Asana is that aim 2 then is we're going to expose these animals to estrogen and testosterone. And then we're going to take out the bone cells and do the same assays. Did the hormonal treatments change the LNC RNA and the ability of melatonin to regulate it? And then does that change the fate? Because I'm trying to figure out why are male and female bones, how they lose bones, and why men die. When men get fractures, they have a very high mortality rate compared to women. But women get more of the bone loss. And so I want to know, is it the hormones? And what are they doing something in the bone microenvironment? And then aim 3 is more the obesity and metabolic pathology. Because when they present with bone loss, it's very different looking than males and females. So the aims are all, I just have to get that methodology for aim 1. It's going to basically be, under different conditions. So looking through these papers is how we do that, and where they find their kits and the controls you're going to use. So it's going to be LNC RNA, sponging microRNAs if there is one for that LNC RNA. What does it do to PPAR gamma, up or down? And how does that impact on the fate of the cell, becoming an adipocyte or an osteoblast? And that's basically what you're both going to do. And we're going to start getting these. I have to see which ones we have inhibitors against and which ones we don't. If we don't have inhibitors, then we just do the mimics. That's the best we can do. So I need for you guys to kind of start writing that up and go through your controls, because those kits will have controls.
Dr. So when you send out us to the table, there is the level which is increased fold or decreased fold.
Yeah.
So
Do you want to look at that really fast?
yeah. So
Who's leaving? Oh my God, another person's leaving. Oh, Julie. Okay.
oh,
Julie.
coach, success coach.
She's a coach
Julie.
now.
She used to be.
There's so many turnover. I don't even know
And
anybody over there.
Janet retired.
Yeah, she was there. I went to her retirement party.
Uh,
Okay, yeah, I just needed it. You have to help me with that one. I don't know what the highlight is.
so
TRAF6, like you just had microRNA, so I don't know what we need to complete that loop. But basically what the data came back as was they compared vehicle to melatonin, this is all from bone, and compared did the LNC-RNA go up or down. So, and I'm trying to choose the ones that had the highest fold changes.
yes.
So that's why I picked these. And that they were regulating PPAR gamma thermogenesis and things like that. So in this table, it's saying that DLU2 compared to vehicle, that the melatonin decreased it by 143-fold. And in this case, there was no difference in the mRNA. But when you looked at the microRNA, you showed that MER2055P, that can sponge that. And as a consequence, and that can impact, scroll that over some more. Can you scroll this?
So it's
TNF, which is more of like that's that interacting protein. So that's more inflammatory.
Yes.
So that kind of makes sense because inflammation makes your osteoclasts get activated. So because some of these microRNAs they might not be good for bone. Like you might want them there or you might not want them there. So if that LNC goes down, I'd want to know, does that MER2055P go up? And if that's the case, is that my phone? And if that's the case, what does that do to the inflammation? So, inflammatory marker. So these are our endpoints. Sometimes we won't have proteins that we can look at. So at a minimum, you're going to do adipogenesis and osteoblastogenesis. And then we go backwards and start looking at the various proteins, kind of like they did in those papers where they look at the interactions.
Yeah.
But I think the first thing would be LNCRNAs, microRNAs, just osteoblastogenesis and adipogenesis. And see what do these do when we add back that LNCRNA. But I want to first know, does melatonin even in these cell lines regulate it? So when did, in this papers, when did they actually, did they do treatments and then, was it like a couple of days? Because sometimes when you'll have a sudden rise and then that sets everything off. And that's kind of what we saw in Maria's paper. She, if we had the inhibitors right at the beginning, nothing happened. But when we started looking at the proteins over 21 days, they actually went opposite. The more you inhibited them, they like compensated and increased. But when you looked at did it turn into an osteoblast, these inhibitors blocked it because it needed that rise at the very beginning, and we blocked that.
They treated before osteogenic differentiation, then they maintained for 2 days for transfection.
Oh, okay. So they did this, and then how long did they? So they transfected it.
2 days.
That's just the kit. So that takes 2 days to get in, and you do lipofectomy. We've done that tons of times here, and then we just we just put them in the osteogenic medium or the adipogenic medium, and then just let it take off.
So you want us to like a something like a
Yeah,
paper
just right-
style,
yeah.
like not like a protocol.
Yeah,
like
and then I'll have to even condense that further for a grant because
Oh, okay.
but I have to know the controls and everything.
Yep.
But when they were doing this, how long did they take their cells out?
Cell culture.
For this paper, it's the same. The cell transfection took place after 48 hours.
Yeah, 48 hours, and then how long did they carry out the?
Then
Every 4
they
days.
Did the
I mean, they
rate
are-
at 14 days.
Okay, 14 days.
Yeah. Osteogenic
14.
injection medium for 14 days.
I'm just saying, like when we add, if we were to do vehicle versus melatonin and just see if these LNCRNAs in the stem cell is the endogenous LNCRNA. I don't know when to harvest that. I don't know if we like do it right away when the thing's still a stem cell, or
Okay.
wait for we would do a time course.
Time, so that's what.
So you're just gonna have to like do like after 24 hours. I would do maybe 48 hours and then do it like key days, like maybe day 5, day 7. But if you can glean data from that, I mean, we might not even have to prove melatonin regulates that. We would just need to show that that LNCRNA does change and manipulate the
osteogenesis process.
But I'm always trying to look at a melatonin effect. I'm expecting to see a vehicle effect, But then I want to know, well, what does melatonin do to that LNCRNA? Does it make it go up or down? Because what we're looking at in that table is what melatonin did in the bone to the endogenous levels of that LNCRNA in the bones. If it's in the bone, I would expect it to be in the stem cell. So let's say we showed a 143-fold decrease. If we were to add melatonin to those stem cells, I would expect that to go down as well. But is that clear?
So
Yeah. You go ahead.
so in our strategy, maybe this one. In our strategy, you mentioned about the
Yeah, I was trying to give you like a for example.
Yeah,
The one
yeah,
thing
yeah.
I didn't
Yeah.
add in here though is the PPAR gamma.
yep.
That has to be added in here.
So I was curious, like so for example, so this is about the strategy is about the mimic of microRNA and inhibitor of microRNA. So
Well,
they-
but they might also have activators and inhibitors of LNC RNA.
Yes,
You have to.
yes.
That's why I need you guys to start researching.
okay.
Companies for those LNC RNAs that I have.
Okay, so because our table we have like up or down regulated one, and then depends on the microRNA level. If the microRNA level is decreasing, then we treat mimics, and then
Mhm.
vice versa.
Yep.
Okay. And then
But
for
I
this
need
one,
to, I should
we
have
have
added
to-
PPAR
okay.
gamma in that. I should have added PPAR gamma in that example I gave you.
Yeah.
So like I was looking at that Limco.
Yeah.
So I'm thinking that PPAR gamma would be downstream of that
Yes.
microRNA.
Mm.
That would be like one of the target proteins that comes before. Like I don't know if PPAR gamma is regulating SIRT and those other things, but the target is PPAR gamma, and then what does it do to the level of PPAR gamma to switch the fate of the stem cell?
Yeah.
So
we
I should have put PPAR gamma
So
there.
we would test PPAR gamma level in every
Everything.
egg. Okay.
Mm.
So for the very first thing we're gonna do is we're gonna culture the cell, and we're gonna divide it into 3 groups: vehicle, melatonin, and melatonin plus 4-PP dot, like inhibitor of melatonin.
Mhm.
And then with each cell line, we would put them in osteogenic media or adipogenic.
Oh.
Both. Okay.
That's why I like that Stem Ex Vivo. It's the
Mm.
same media. It just has different supplements.
Mm.
The only problem with the last time I used it, it didn't do the it didn't cause osteoblasts to occur.
So then after, like we'd see for 21 days we'd grow the cells, and we'd do the time course.
Well, so
After adding the media.
what
we'd
was the
go
what's your first study though? So you're doing so what I mean we can instead of doing I don't know this is where I got to figure this out. So I would like to know, does melatonin regulate those LNCRNAs and accompanying microRNAs? But the microRNAs, that's all RNA work. So I'm thinking maybe not worry about that right now and just see if we stimulate or inhibit those LNCRNAs and microRNAs, does that impact on PPAR gamma and melatonin's effects on the cells?
Okay.
So the vehicle is going to pick up just the LNCRNA, microRNA effects, right, on PPAR gamma and whether it turns into a blast or a adipocyte. The melatonin, though, is an upper level of regulation saying, is that melatonin regulating that LNCRNA to affect the microRNA, to affect the PPAR gamma, to affect the fate? And then the 4-PP dot, is it happening through receptors?
Or receptor independent. Okay.
So I would,
So at the end of 21 days, we would go in, we would measure the LNCRNA, like our targeted LNCRNA, and then the related.
yeah, but that's all RNA work. Right now, I would just want to know what happens. I'm keeping it simple.
Okay.
You're going to transfect in the LNCRNAs or microRNAs, vehicle or melatonin. You're going to run those assays. You're going to see if they turn into a blast or a clast. And then you're going to also take out some cells and look at PPAR gamma levels. That's it for now. That's easy. Like that's the simplest. Then we see which ones are working, which ones are not. And then we backtrack and then we start doing other things. Does that make sense? So vehicle mel plus 4-PP dot. Then we're going to transfect in the LNCRNAs, microRNAs. Then we're gonna look at PPAR gamma through westerns, and then you're looking at blastin adipocytes.
That's to alizarin and oil rest.
Mhm.
Gotcha.
Because, and we're only measuring extent of formation. So let's just say that, you know, I don't know which one regulates rungs too. Which one was that? Look at the table. There's the tug. So tug can regulate. So and again, that's what they have the potential to regulate. We don't know if they're going to regulate that. But let's just say an increase in tug decreases the microRNA that's actually inhibiting RUNX2. So if you decrease that microRNA, you're going to increase RUNX2. So what I would want to know is, what is melatonin doing? I mean, melatonin should be inducing RUNX2.
Yeah.
Yes.
And that's what's causing them to turn into osteoblasts. So I would want to...
Melatonin affects talk.
Huh?
Like
What?
So if we see like a melatonin increase talk.
Yeah, so I would want to look at tug, and I don't know if that's a protein.
That's the I don't see the data. No, for the.
Which
no,
one?
I was just curious. This one is a melatonin treated one.
Yeah.
Right?
So,
So it's showing. Looks like.
but see now, so I'm like, okay, because this is, again, these are LNCRNAs, right?
Mm-hmm.
So that tug, that all caps, that's because usually that indicates a protein.
Yeah.
So we have to be careful how we're writing, because italicized usually means the gene. So I don't know if that should be italicized.
So that written in the mouse LNC was upper, lower. Human was all upper. That was LNC, RNA. Something like you were saying something.
What?
Something like so for example this one is human, and because it's all upper, and
Oh, yeah,
something
yeah.
like
So when you're writing those axes out, were those italicized? Was that tug one a protein, or was it? That has to be go back in that reference, because it matters if they're all caps.
Yeah.
It matters if they're italicized. Proteins are usually just all caps. In the olden days, it used to be all caps was human protein.
Okay.
The first letter capitalized but still non-italicized meant like a rodent.
must be.
But I think they just do all caps now for proteins.
Must be reference 1 to 3. Oops.
But like, let's just say that was RNA. So you saw that tug regulated that microRNA, which regulated rungs, right? So I would want to know first, if we add that tug, LNCRNA, and add a mimic of that, transfected it into the cells, I would expect that RUNX2 to go up, and I would expect to be more osteoblasts and less. Well, let me backtrack. We have to fit PPAR gamma in there somewhere, because so I would say we'd look at tug, mimic, sponges, that microRNA. I would somehow, if RUNX2 goes up, I would think PPAR gamma would go down.
Yes. Because adipogenesis functions to PPAR gamma.
Mm-hmm.
Yeah.
So we would look at PPAR gamma,
Mm.
RUNX2, and then blastin adipocyte. So I would expect the extent of osteoblast to be increased in the melatonin compared to vehicle, and the extent of adipocytes would be decreased. But where I need your help, because it's going to help you with your protocols anyway, I need you to look up all these things for me,
Yes.
because I can't do all that.
Yes.
I need to know, are there kits? Is there something out there I can buy for the LNCRNA?
Yes. So this one was LCRNA top one.
Yeah. So I think, so we just have to look at how they write that out.
Yep.
Yeah, they just write it out. LNC tug 1 RNA. I'm assuming because they're sponging the
Yeah.
microRNAs.
Yep.
So does this make sense now? But do you see how it's like sequential? You got to like write out the axes. So we could even just write it out like here. So go. I'm not erasing this because I like this. But we're gonna go. We'll say vehicle mel plus 4 pp dot, right? Then we have the tug. So let's do this example is tug 1. It's tug 1, right?
Yeah, tug 1.
Yep.
So then we do MSCs. We're going to transfect in tug, right?
Okay.
48 hours. And then I'm expecting that to decrease that microRNA, whatever that name was.
23p. 23p.
B.
Yeah.
If that goes down, we're going to look at rungs 2. That should go up. I'm thinking PPAR gamma should go down. And I think that should increase osteoblast. And I think this should result in a decrease in adipocyte. And we're going to do this same thing over and over again. But again, some of these LNCRNAs don't have that.
Yeah.
And there won't be any, and there will be some LNCRNAs that the company won't have a kit for. So I just need you to go through every one of those that you found, the LNCRNAs and the microRNAs, and just set and find if there's a kit or not. It's going to change the approach. For sure, we could make mimics of everything because you just have them sequenced. That's why they have those just sequences. You have a company just make those. And the transfections are really easy. Lipofectamine, like I said, you're basically taking liposomes. You just put it. It's really easy. Put your DNA in there, shake it up,
Yeah.
lay it on the cells,
There are
and they just go right in.
Detailed protocols on that.
Yeah.
Thermo Fisher has it.
So but we need to have the controls. And so you said they had the dual luciferase. That's if you're looking at the LNCRNA microRNA interaction.
Yeah, interaction. Yeah.
That would come later. That would come in. I just want to first screen all these and just see which ones do we target from there.
Okay.
And then we get into more of the fine tuning of who's regulating what. But my goal, my focus right now is that PPAR gamma, all of those proteins we're assessing, because I think they're changing the microenvironment. I think that that's explaining why male mortality goes up, and it might be hormonally driven. I'm thinking also with obesity, the high fat is changing things. It was very interesting. The high fat diet can make estrogen, which actually can be bone protective.
Yeah.
But then it can also throw off adipokines, which inflames it. So right now, I'm trying to keep it simple. But I need you to write me up something like this, and I need the companies. So just kind of in that table I gave you, just put down what we have companies that I can buy kits from, because I have to come up with a budget. But that'll be fun. You guys get to start doing some fun stuff like that. We'll be little molecular cell culture people. We still try to keep doing the Western blot so you don't lose your technique. You get really good at it, and then we go into the cell culture work, and then you go back to the Western blots, and you're like, oh my god, I lost my skills.
Yeah.
But so you'll go back and reanalyze your data. You'll go back and do the big boxes.
Do we have anything for the fridge in there?
No, and I checked.
Okay.
I cleaned pretty much all that out. The only stuff that I have is in that freezer in Dr. Day's, that big freezer.
Last time I've seen in Apsana.
Yeah, we all cleaned out those freezers.
Yeah, we like she said, we only have in Dr. Bay's freezer, and the rest was cleaned up.
Yeah, and I think I also have boxes in that cell culture room right across from Dr. Bay, that corner. When you're sitting watching the football field.
Yes.
It's that cell culture lab right across from her lab. We're in that freezer. That's right. We're in that freezer too.
Yeah.
And I know we have all our cell culture stuff in the freezer in the cell culture room.
Yeah.
But is that pump hooked up in there?
So right
CO2
now,
tank should be coming, like go check downstairs, because, but Dan has to show you and
Okay.
Dr. Leek wanted Muslim to watch
and,
too.
yeah, Muslim asked me.
Yeah,
like,
you, so
this
it,
call.
I ordered it, so
Yeah.
it should be coming
Yeah,
in, so
yeah.
it'll have my name on it downstairs.
Yeah.
Okay.
But, so Range, do you know Dan?
Yeah.
I'll be very, like, he's great.
Yeah.
Like, be friends with Dan.
Yeah, yeah,
Say, is there a time that you can show all of us?
Okay.
So I'm counting on you guys to look downstairs
Yeah.
for it.
Okay.
It'll be in the, where they store the tanks, my name will be on it.
Okay.
Sure.
Got it.
Cause they're down to a half, we have to have two,
Yeah.
and I don't wanna ruin any of their stuff.
Yeah.
And then tomorrow we have 2 participants, I'll be here at 8 in the morning. And then we have another one at what time?
11.
And I'll be here then, I'll just work on my grant sitting over there. But it's all come together. And I'm excited, I didn't look at all the data, so I'm glad there's some significance with stuff.
Yeah.
And then just reanalyze your bands. Because the trisol extracted runs too, like that's kind of like a positive control. But I don't think you were getting everything.
Yeah.
But your bands look good.
The pens are good.
And use the polyclonal for the APAR gamma.
Yeah, the ones I'm going to redo, I'll use the problem.
Yeah, and then we have that rat, because I know I had like different secondaries.
So that was, I think,
I had like mouse rat.
I checked in and we have the for
600.
the green, the red. We have for the 700.
Yeah,
and
you
red.
should have them all. You should be able to do
Yeah,
them all. Because we used
yeah.
to, before we moved to revert 700,
Yeah.
we did both. We would add in.
Because I asked him like we used to we used to use 700 and then we can't use because of
Oh.
you're staying and
Oh,
he
yeah.
said you can use what are you talking and I was like how and then he was like use it but the key was use different hosts. That was Rachel also told me and then what they're doing is use a different host and then something like but usually we have mostly like a mouse or like
Yeah,
just
well,
rabbit,
I
but-
purposely will buy like rabbit, anti-rat. I'll buy rat. There was, I even had I can't remember that other strange species I had.
So for the red channel, as a secondary antibody,
You
we have
have-
goat anti-mouse,
Yeah, goat.
goat anti-rabbit,
Mm.
and then rabbit, and then donkey, and then
Yeah, donkey.
something. I
So
just
good.
saw it. I forgot.
And that's actually good that you're doing the inventory because now you know what we have.
Yeah.
But yeah, and so I'll be in tomorrow, and then just keep working towards this and get those protocols to me as fast as you can.
Yeah.
And I'm trying to just stay home and write my grant. So tomorrow I have my grant meeting, but I'll first come in here and then we'll go back to doing that. But keep up the good work. So we finished up another clinical trial person. How many is that now? 21?
21.
Finishing up a couple. So anyway, she had good results.
Yeah.
All right, I'll see you guys.
The one. Thank you so much. Please, we want only the Brazil
Have my lunch and then start the stripping. So
I think.
why do you suggest using polyclonal instead of monoclonal?
No. I asked the company and they use different channel. And when I found it, I took one. We only have the red, which we can use the 700 as well. I checked. It's inside of there. We have only one that we have.
So that's the rabbit polyclonal.
So that's for LC. trick just to use that one. Then should be show up like on the legend.
I can do I'm just wondering, do I use the same hypergamma membrane or use another protein membrane? Like, do I keep the SK30 and then add 40?
Original discussion is stripping and use that one. That's
But
the
that
original.
hypergamma is a
Use
very old membrane. Like I did it at the beginning of June or at the end of May. So I'm just not sure whether. I mean, it's a very old membrane. I did hypergamma.
as long as it's wet, I think it should be okay. Though.
Yeah, that's.
Mm.